This is Daniel Winkelman, and I did circuits and microcontrollers for my tools mastery. The dorm sign I designed is interactive with passersby. Apart from my name, the sign also lists a question to which people can answer yes or no. The sign has two buttons to collect this input: flashing LEDs to show the user that it counted their vote, and an LCD display that shows the cumulative tally of affirmative or negative responses. In order to prevent spamming, the microcontroller blocks new input for 5 seconds after a button is pressed. The dorm sign could be fixed to a door using Velcro straps. The sign can be broken down into 4 main modules. The first is the buttons, which serve as inputs for the system. They are set with a pull-down resistor so the Arduino listens for a low to high edge. The second is the LCDs, which respond immediately to the buttons and serve as an output. The third is the LCD display, which serves as a higher level output set. The LCD is capable of displaying the higher level strings. The LCD also receives custom-defined arrow symbols. Finally, the microcontroller ties all of these input and output subsystems into a coherent device. The first step in producing the sign was to experiment with the Arduino. I consulted a couple sample programs for basic pin input and output and the LCD screen, as well as Arduino API documentation. The book supplied with the Arduino was particularly useful in quickly setting up circuits, especially for the LCD. The second step was to define the functionality I wanted the dorm sign to have. After talking to a few friends for inspiration, I settled on the voting idea. The next step was to make a rough prototype of the circuit and write an essentially complete version of the program. After a successful circuit design was made, I soldered the components the user interacts with to a PCB board. Once this higher fidelity prototype was made, final assembly was done inside the box. The biggest challenges I encountered were mostly with final assembly steps. Soldering as a whole was successful, but it took a long time to arrange the components on the board, fix them in place, apply solder, and make sure solid solder bridges between connections got made. When I began assembling the final connections, several of the wires I soldered to the PCB board snapped because they were weakened with age. This meant I had to go back, remove extra bits of wire, and solder around my existing joints to add replacement wires. Finally, finding time-effective ways of attaching the components in and on the box was challenging. Since I've had a lot of experience with programming, I was able to anticipate the effects of code changes accurately. When I was setting up the LCD display, I wanted to include custom characters. However, I was not sure of the initialization order of the code, so I needed to experiment with different combinations of orders and omissions. I finally settled on the correct sequence through the process of elimination and trial and error. Additionally, when I was conceptualizing my design, I was considering scrolling the question across the LCD display instead of fixing a static sign. However, I decided against this since the LCD can only contain 32 characters at a time and it would be hard for users to read. In conclusion, I enjoyed this project because I was able to expand my programming repertoire into circuits and microcontrollers. I learned techniques for making code work in the physical world.